Hello friends and welcome back to my channel. Myself Ashfaq, and in today's video I will show you how to create a simple RAG pipeline using Langchain, Hugging Face, chromadb and the OpenAI. So let's start building our project. So before starting I will show you some prerequisites for this project. You need to install the Anaconda. You can download it from here and you can install it in your local system. You can download and install the Python from here. After installing the Anaconda, it will ask for the installation of Python. You can directly go ahead and proceed the Python installation after the Anaconda also. Or if you want to separately install, you can install it from here. And you can install the VS Code from here. So these three softwares are the prerequisites for this project. In my local system, I will create the folder for my RAG project. I will go to VS Code and open this folder. I will open the terminal from here. For this project, we are going to use the UV package manager. So first of all, I will install the UV under my project. Pip install UV. Now I'm going to create a virtualized environment by initializing the directory. So for that I will give the command uv init. So our project directory has been initialized using the uv. If you are still not having the Python in your system, you can go ahead and install the Python using this command. I'm already having the Python in my system. If I give the command python hyphen version, so this is the Python version installed in my local system. So next thing is to create the virtualized environment using Python and to activate it. So for that I will give the command uv venv, and now I need to activate it. So I will give this command to activate it. Now I need to install the requirements for my project. So for that I will go ahead and create the requirement.txt file under my project directory. I will give the requirements for my project here. So these are the requirements. I will close this terminal. You can remove anything if you don't need for your project. So like I don't need this rank BM2, and don't forget to tick this setting, auto save. Otherwise your files will not get saved, or you will have to save it manually. I will again the terminal. I will give the command to install the requirement file uv add requirements.txt. All the required packages and libraries for my project have been added. We are going to use the Jupyter notebook. So to use the Jupyter notebook under the VS Code, we need to add it through UV package manager. So I will give the command UV add IP IPY kernel. IPv kernel edit. I will create new file. I will select the kernel and I will select this kernel which is inside my project directory. So kernel has been selected. I will close the terminal. I have done the OS import. Now I will, sorry, after this, I will load the, I will load the environment. I will execute this cell. So environment variable has been loaded. Now this is the time to import some libraries from the Langchain. So this test splitter is needed to split our uh, text into the chunks. It will import the text loader it is required to load the text, and then from langchain underscore core dot documents import document, and it is required to save all our loaded documents inside this document. This is actually class. So all the text which we are going to load, we are going to save it under this class, which is document. For vector store, we will import so we are importing the chromadb from the langchain. And here we are importing the numpy and the list. One thing is remaining, which is for the embedding. From langchain underscore hugging face import hugging face embeddings. So this is the open source embedding model of the hugging face. We are going to import it from the langchain, which will convert our text or our document to the chunks. I will execute this cell. I will correct the name here. I think it should be capital L. Yes, correct. I will again run it. So now it is successful. I will now go ahead and create the directory under my project called data, and inside it I will copy the three sample file data file, which are the text file, which we are going to import, which we are going to load actually. So these three are my sample text files. First one is simple how to debug Terraform. Second one is what is large language model, and the third one is what is machine learning. So these are the sample three text file we are going to load today for our testing project. So if I refresh here, so data directory I'm able to see, and I'm able to see the three uploaded text files also. Now we have to load the documents from the directory. So for that we need to import one library from the Langchain. From Langchain community document loader, import directory loader and text loader. So it will load the directory loader, so which is going to load the all documents present under the particular directory, which we will be giving, and it will also load the text files. So these two loaders we are going to import from the Langchain, and next we are going to load the documents, our sample documents. So it is going to load the documents from the uh, directory called data, which we have created, and it will load all the text document.txt documents from this directory, and all these documents will get added under the class documents. I will execute this cell. Okay, so three documents have been loaded. If I execute the documents, so it will show what are the documents has been imported under this class. So these three documents it is showing which have been loaded. Now we have to perform the document splitting. Means we are going to split our documents to the different chunks. For that, I will first initialize the text splitter, which is our recursive character text splitter, which we had imported from the Langchain initially, and chunk size would be 500, and overlap chunk we are giving the 50 to maintain the context, and and all the documents which are the under the documents class will be splitted and saved under the chunks. And here we are going to uh, print print the chunks and the their metadata. I will execute this cell. So it has created 14 chunks from the three documents. It is showing the content and the metadata also. If I execute here the chunks, so it should return all the chunks inside it. So these are all the chunks inside it. We have to now initiate the chromadb vector store. So I will give the code here. This persist directory would be created chroma_db, and we would be using all mini lm L6 field 2 model of the Hugging Face for the embedding, for converting our chunks into the vectors. And this is the open source free to use embedding model, and this would be the collection name, means vector database name. I will execute this cell. We can see here chroma_db directory has been created. If I give here the command vector store, so it will show the which vector store we are using. Now we can do the similarity search into our vector store or chromadb. I will give this command. So this is our query. What are the types of machine learning? So it will do the similarity search into the vector store, and it will provide the top 3 results, k equal to 3, and those results would get saved under the similar underscore docs, and finally it will print the result which is inside the similar underscore docs. I will execute it. So this is the result of the query which has been retrieved from the vector store, but it is with the metadata. So we can print it into the readable format using these commands. So it has printed the top three similar chunks for our query from the document, from the vector store. For our project, we are going to use the OpenAI as the LLM. So you can go to this URL and sign up here for the OpenAI using your email ID, or you can also sign up with your Google credentials. I have already logged into the platform.openai.com/API-keys. I'm now going to create the new API key for my project. I will click here, create new secret key. I will give the name I will copy this key locally somewhere on my system. I will go to VS Code and inside my project I will create the file with the name .env, and here I need to save my API key. I will type here OpenAI underscore API underscore key equal to, and I will paste my key which has been copied from the OpenAI portal. I will save this file, and on my Jupyter notebook I will give the command from .environment import load underscore .env. I will execute this. It is asking me to select the kernel. I will go ahead and select my kernel. So this was my kernel. I will now go ahead and define the API key which has been created. So it is giving me error. I will go back to my first block and I will execute it again. And again I will execute this key command. Okay, now it was successful. I will now go ahead and import the OpenAI from the Langchain. So I will give the command from Langchain underscore OpenAI import chat OpenAI, and we are going to use this model GPT 3.5 Turbo. Uh, this model of the OpenAI we are going to call for our project, and this is the simple query we are giving to the our LLM. What is the large language models? I will execute this cell. So this response has been provided by the LLM, and there was a API call made to LLM, and we got this response for our query. I will now go ahead and call the chat model. So first of all, with this command I am going to import the chat model from the Langchain, and then we are going to call this chat model, OpenAI chat model. I will execute this cell. I need to now import few libraries from the Langchain which are required for the final rack chain. We are first importing the retrieval chain which will actually provide the retrieved content as the context to the LLM. Then we are importing the chat prompt template and we are importing the create stuff document which is required to uh, stuff all the related chunks or retrieved content to provide it to the LLM. I will go ahead and execute it. Now we need to define our retriever, and retriever would be our vector store. K equal to 3 means it will retrieve the top 3 relevant chunks. I will execute this cell, and if I give here the command retriever and execute it, so this is my retriever which is the chromadb from the Hugging Face. We need to now create the prompt template. We are creating the prompt template to provide the retrieved content as the context to the LLM. So this would be our prompt template. I will execute this. If I give the command prompt, so this is my chat prompt template. We need to now create the document chain. So create stuff document chain creates a chain that stuffs, that inserts all retrieved documents into a single prompt and send it to the LLM. It's called stuff because really it literally stuffs all the documents into the context window at once. Whatever relevant information we are getting from the retriever, we are combining them and putting in prompt template under the context. So I will give here these two lines. So document chain would be create stuff document chain which is having LLM and the prompt. Before it we are importing the create stuff document chain from the Langchain. I will execute this cell, and here if I give the command document chain, So it will show the document chain which we have given, here. We need to finally now go ahead and create our final rack chain, for which we need the create retrieval chain. Retrieval chain is a function that combines a retriever with a document chain to create a complete rack pipeline. So for that, first I need to import the create retrieval chain from the Langchain. So I will be importing it with this command, and here I am creating my final rack chain, and I am giving the name it as rack underscore chain, which is having the retriever and document chain. I will execute this cell. If I give here the command rack underscore chain, so it will show what are inside our rack chain, which is our final rack chain. I will now go ahead and query my rack chain. So for that I will give this command response equal to rack chain. We are invoking our rack chain, which has been completely built till now, and this would be our query, and it should retrieve the answer from the vector database. I can print my response. So this is my input, and it has given the top 3 result for my question, for my query. I can print it in better way. So this is the answer from which has been retrieved from my vector store by the rack chain. We will test it again. I will give the one more question. What are the key Terraform debugging techniques? And I'm printing my answer here. So it has retrieved the answer from the vector store. So what is our final rack chain is doing actually? It takes the retrieved documents, stuff them into the prompt, which is the context placeholder, into the prompt template, sends the complete prompt to the LLM, and returns the LLM's response, which we get it here. By this way, you can create a simple rack chain using Langchain, chromadb, Hugging Face, and the OpenAI LLM. And you can invoke your rack chain. You can get the answer. You can get the answer from your documents which you had provided. Hope you find this video helpful. While practicing this project, if you get any type of error, any type of doubt, you can ask me in the comment section. I will definitely try to answer them. Like this video Share this video with the friends and spread the knowledge. A lot of effort went behind this video, so do subscribe to this channel to encourage my work. I will see you in the next video. Thank you.